Welcome back to this video tutorial. We can discuss about the addressing modes of 8086. An instruction which has a format and it has one or more number of fields associated with it. And then basically the first part is an code part or the operation code part, which indicate the type of information or type of operation to be performed by the CPU. Type of operation to be performed by the CPU. Next is the operand field. CPU execute the instruction using the information which is reside in this field. The operand field indicate the data on which the operation we want to perform. And about this addressing modes. Addressing mode indicates the way of locating data of or these operands in an instruction. Okay, addressing mode indicate the way of locating or identifying the address location of operands which is present inside the instruction. We have different addressing modes. The first one is the immediate addressing mode. In this immediate addressing mode, the data on which we want to perform the operation is directly available in the instruction itself. Okay, so this one example, this is a data transfer example. Move AX, 0005H. The data we want to transfer to register AX is directly or immediately available in this instruction. So this particular instruction follow an immediate addressing mode. Okay, meaning after executing this instruction, the data directly available here, that is the 0005H, become a content of register AX. Next is about the register addressing mode. Here transfer a copy of a byte or word from the source register to the destination register. In the instruction for a register addressing mode, the data to be transferred is available as a register content. So consider this example, move CX, DX. That means after executing this one instruction, register content of DX now become a copy of this register CX. Register DX content is copied into register CX after executing this one. Suppose the content of DX's register is like this 1FA3 as 16-bit information, and the current status of this CX register is like this 76AF. So after executing this, the current content of the CX register get replaced with the value of this DX register, that is by this 1FA3, because the content of this register DX is copied into register CX after completing this execution. So this is an example for register addressing. Next is about the absolute or direct addressing mode. In it, a 16-bit memory address or the offset or displacement value of an operand is directly specified in the instruction as a part of it. The displacement value of the operand or the data to be operate is specified as a memory content here. Example, move AX, content of a displacement value. This is the general syntax. An example, move AX, content of 1234H. This indicate inside a particular data segment at a displacement position or at a offset position 1234, we have the content that we want to transfer into register AX while executing this particular instruction, move AX, content of 1234H. Okay. So how can we calculate the exact physical address for such a instruction? Once more, what's the meaning of this? We need to transfer a content from a data segment register which is present at a particular displacement or offset position. Inside that data segment, the displacement value is 1234H, which is available in the instruction. So in order to get or calculate the exact physical address, we need to make this 16-bit of information into 20-bit address information, because 8086 is associated with a total of 1 MB of memory. In order to address each of this byte of this 1 MB memory, we need to make the 16-bit of information into a 20-bit address information. So in order to perform that conversion, 16-bit information to 20-bit address information, we have already learned the method, that is, we want to perform the segment address information into 20-bit information by performing 4-bit left shift operation, or we need to perform a multiplication by 10h. Then after that we need to add the displacement value which is available from the instruction itself. So here suppose here it is the instruction we are going to execute, move AS comma content of 1234H. This indicates the displacement value. And suppose the data segment address which is available in the data segment register is 1000H. How can we calculate the effective address? Multiply this with 10H and it become the 16-bit address to, or convert this after performing this multiplication, the 16-bit DS register content become 20-bit. Now this 10000. Okay, then we can add this displacement value 1234 and the exact physical address here is 11234H. So in the 1 MB memory at location 11234, we have the data that we want to transfer into register AX. Okay, so in the memory starting from the location 11234, we get the data 16-bit information we want to transfer to register AX is available from a starting address 11234 inside the 1 MB memory. So using this 11234 and the next 11235 address information, two consecutive address or two consecutive bytes, we can load these address or content from these two consecutive byte into register AX. So this 8A comes here and this 0F comes here. Okay, so this is the case of absolute or direct addressing mode. So next is about register indirect addressing mode. Indirect, register indirect. This addressing mode allows data to be addressed at any memory location through an offset address held in any of the following register: BP, BX, DI or SI. Okay, that means the offset or the displacement value is given in the instruction as a register content, and the register may be BP, BX, DI and SI. Consider this one example. Move AX comma BX. That means BX is a register. That register hold the address, memory address information. That address actually indicate the displacement value. Okay, so consider this one instruction and this one example. Move AS comma content of BX and BX. Suppose the value of BX is 1000H. This is actually a memory address information. And also we need the data segment register or content, data segment register content, which indicate the starting location of the data segment in which we need to perform this data transfer, or we get the data to be transferred into register AX from a particular data segment whose starting address is available in data segment register. Suppose the value of that particular data segment is 0100H. Okay, so while executing this particular move AX comma content of BX instruction, what will happen? We need to convert this 16-bit information available in data segment register into a 20-bit information by performing this 10 into 0100. Okay, perform a multiplication with 10 and we need to add the content of register BX. And here it is given that the BX register currently contain an address information, that is 1000. This particular information, address information, actually indicate the displacement location or the offset location inside a particular data segment. For that particular data segment, the starting address is available from this data segment register. So in order to get the exact physical address from the 1 MB memory from where we need to transfer data to register AX. We need to perform all these operation. First perform this multiplication, then want to add the content of this BX register, and as a total now we have the exact 20-bit physical address, that is 02000H. In the 1 MB memory starting from 02000H, and we need 2 consecutive bytes that is available from this particular address location and from 02001 also. So these are the 16-bit of memory content we need to transfer into our register AX. So this 34 comes in the higher byte of AX and 1A comes in the lower byte of AX. So this is the exact meaning of this particular instruction, move AX, BX. Okay, so this particular, if the instruction is available like this in our instruction or the program code, this one indicate the register indirect representation of our code or operand value, or this is the register indirect representation of an instruction. Okay, next is about the base mode. Base mode means the effective address is the sum of the base register and displacement. Exactly like this register indirect addressing mode, sometimes the offset value is represented using a base register. Then this is a special case of this register indirect, that is the base register indirect addressing mode. Okay, that is here the address is represented, this effective address is represented as, or the offset value is, or the displacement value is represented as a sum of base register and a displacement value, and the instruction look like this. Okay, this is actually a modification of the case register indirect addressing mode. Like here the displacement value is available through a register, base register, and with the displacement value. Similarly, we have this index mode in which the displacement value or the offset address is available or represented in the instruction as a content of a memory location which is available from some index register, and also we need to consider the displacement value available in this instruction. Okay, so based on this based indexed mode or base plus index addressing, so consider this one and follow this next addressing mode, that is based indexed addressing mode or base plus index addressing. In this, the effective or the physical address effective physical address is calculated as a sum of base register and index register. Base register means BX or BP, and the index register is SI or DI. So instruction look like this, move AL, content of BP plus SI. So the effective address or the offset value or the displacement value is represented in this instruction as a content of base register plus a index register, and the base registers are BX or BP, index registers are SI or DI. So in this base mode we need to specify the offset value using a base register BP or BX plus a displacement value available in this instruction itself. In the index mode we need to specify the offset or the displacement value as a content of index register and a displacement value. Okay, and based indexed mode or base plus index mode, in which the instruction look like this, that is the displacement or the offset value is represented in the instruction as a content of some base register plus some index register, like this. Okay, so consider one example. Operation is move DX, content of BX plus GI. How can we calculate the exact physical address using this information? We need to focus on the segment address, data segment address. Suppose the data segment, or some, if we want to transfer some code information, in that case we need to consider the code segment address. Here it indicates a data transfer, so we need to consider or focus on data segment register, that is 0100H. Okay, and the BX register content is assumed as 100H here, and the DI content is assumed as 0010H. So this is our memory, and these are the status of our various base register and index register, and this indicate the data segment register starting address. So first perform this multiplication with 10 and become a 20-bit information. Convert this 16-bit into 20-bit, that is 00100, and want to add the content of BX register as well as with this destination index register content in order to get the exact 20-bit physical address. So we need to add this value with the multiplied value, and also we need to add this DI register content also. Okay. So this is the result of after this multiplication and addition operation, that is 0 to 010. In the memory, move to that particular location and consider the value data available in 2 consecutive bytes starting from that particular address location, and it is 03AB. So transfer this information to our destination register. Destination register, here it is DX. So in DX, first move this 03 to the lower byte and next AB to higher byte. So this is the meaning of this type of instruction available in our program code. Okay, this one indicate register which type addressing mode, base plus index. That means the displacement value is represented as a content of some base register plus index register content. So this is an example for base plus index addressing mode. Next is register relative addressing. That means the offset value or the displacement value is represented in the instruction as a relative value with respect to some register, base register. Okay, so consider this one example, move AX comma content of BX plus 100H. That means the displacement value inside a particular data segment or some code segment or some data stack segment. Here it is, we are considering data transfer operation, so focused on data segment register. So that means we need to transfer data inside from a data segment to some register. So the data segment starting address is available from data segment register. So inside a particular data segment whose starting address is available in data segment register and is assumed at 0200 here. Okay, we need to calculate the displacement value or the offset location inside that particular data segment using this information which is available in the instruction itself. Okay, so this is the status of memory. Here we need to transfer data from this particular location inside a data segment to register AX. Suppose we have this register and BX with the value 0100 now, and the data segment register is assumed with a value of 0200H. Okay, so calculate the exact physical address using this information. This 0200 is multiplied with 10 and become 2000, become a 20-bit information. Now we want to add this with the content of BX register and also with this displacement which is directly available here in this instruction. The BX content is 0100. Also add this direct displacement value available in this instruction, that is 1000, and get the exact physical address, that is 03100. From starting these address information, consider two consecutive bytes, that is 03100 and at 03101 we have the 16-bit information 76 and A0. So move this information to our 16-bit destination register AX. 76 to the lower byte and A0 to the higher byte. Okay, so after executing this is the status of our AX register. Okay, next is about base relative plus index addressing. Base relative plus index addressing, in which base relative plus index addressing, in which the displacement value is represented as a content of any base register and any index register and with the displacement value. All these are directly available in this instruction itself. And the starting address of the data segment, from which we need to find the displacement or the offset value, the starting address of that particular data segment is available in our data segment register. So how can we calculate the exact physical address? Perform the data segment register content into 10, then add the base register content, the index register content, and with this direct displacement value available here. So after this multiplication and addition operation, we generate the exact physical address location at 20-bit exact physical address location, from where we can transfer data to our 16-bit AX register. So suppose DS register with content 1000, that indicate the starting address of the current data segment is thus. Perform at an 4-bit left shift or make it as 20-bit address information by performing multiplication with 10. Then add the value of BX register, that is 0020. Okay, add this multiplied value with BX register content, DI register content. BX register content is actually BX0020, and with destination register content 0010. After adding these two, we get the value 0030, and also add this direct displacement value available here in this instruction, that is 0100, and as a total we get the sum value 0130H. Add this sum value with the multiplied 10000 and get a 20-bit exact physical address as 10130H. This is the exact memory location in the 1 MB memory of 8086, from where we can transfer 16-bit of information to our destination AX register. This 16 is transferred to lower byte of our AX register, and this A3 from 10131 address location transferred into higher byte of AX. Okay. So all these are different addressing modes. Next, we need to consider some other point, that is, in general we have two types of instructions: sequential instruction and control transfer instruction. Sequential instruction means for a given set of program codes, the instructions are executed one after another in a sequential mode. But in control transfer instruction, while we have a set of instruction or a program code, in certain situation, after executing certain instruction like condition checking, we need to transfer the control to some other instruction which is not present sequentially just after that particular instruction. That means we need to skip certain sequential instruction from or which comes just after the currently executing instruction, and we need to transfer the control from the current executed instruction to somewhere which is not sequentially present just after that instruction. Okay, so such type of instructions are example for control transfer instruction. Okay, so for the control transfer instruction, The addressing modes depend upon whether the destination location is within the same segment or different one. Okay, we have already said this control transfer instruction. Control transfer means transfer control to a distant location which is not present sequentially just after the currently executed instruction. In that case, we have different situation like transferring control to a location which is present inside the same segment. Now the control have, or some other times we need to transfer the control to some other location which is present in some other segment itself. Okay, so we need to transfer the control inside the same segment, or sometimes we need to transfer the control to some other segment. Okay, based on that we have two types of addressing modes for the control transfer instruction, that is intra-segment addressing and inter-segment addressing. Intra-segment means the location to which the control is to be transferred is directly available in the same segment in which the control is now present. Okay, and in case of inter-segment, we need to transfer the control to a distant location. That location is present in some other segment. Okay, this is about inter-segment mode and intra-segment mode. Okay, based on that, for the control transfer instruction we have inter-segment control transferring or intra-segment control transferring. For the intra-segment, we have intra-segment direct mode and intra-segment indirect mode, and similarly for inter-segment we have inter-segment direct addressing mode and inter-segment indirect addressing mode. In intra-segment direct, address to which control to be transferred appears directly in the instruction as an immediate displacement value. Direct means, or absolute means, this is not like absolute, this is like immediate addressing. Intra-segment direct means the control to be transferred, the location to which the control to be transferred is directly available in the instruction as an immediate displacement value. Okay, in this mode, the displacement is computed relative to the content of the current instruction point content. Because intra-segment means transfer the control to a location which is present inside the same segment, so that the segment address is same for both the instruction, that is for the currently executed instruction and for the instruction to which the control is to be transferred, both present in the same segment, same code segment, so that we need to consider the displacement value only. The displacement value is available from this instruction point. Instruction pointer always pointing to the next instruction to be executed, right? So in case of intra-segment direct addressing mode, the displacement value is directly available in the instruction. Okay, so in order to calculate the exact physical address, no need to change the segment address, because both the instruction address present inside the same code segment, so that we don't want to change the segment address. So the code segment address is same for both the currently executed instruction and for the instruction to be transferred the control. Just want to consider or calculate the displacement value, and the displacement value that we can calculate with respect to the instruction pointer value. The instruction pointer value hold the displacement value. Using this, we can calculate the displacement value of the next instruction to be executed, which is present in a distant location inside the same code segment. Okay, and in case of intra-segment indirect, the displacement to which control is to be transferred is indirectly present in the instruction as a content of register or memory location. In case of intra-segment indirect, intra-segment means the control to be transferred to a new instruction, that instruction present inside the same code segment itself. Okay, so we don't want to change, or we don't want to consider the code segment address, because the code segment address of the current instruction that is executed and the code segment address of the instruction to which we need to transfer the control, both are same, the same code segment address. But here it is an indirect method. That means the displacement value is indirectly represented in the instruction as a content of memory location or content of register. Okay. Next, about the inter-segment direct. Inter-segment means the control to be transferred to an instruction which is present in another code segment. Right. So in that case, we need to consider the new code segment starting address also, and inside that code segment we need to calculate the displacement value. So inside the instruction we need to specify the code segment address of new instruction, as well as in that code segment we need to calculate, or we need to fix the displacement offset value in which the instruction is present. So in case of inter segment direct mode, inside the instruction we need to specify both the code segment address as well as the displacement value using this instruction pointer, okay, which is in a direct way, that is as an immediate value in the instruction. In case of inter segment indirect mode, inter segment means in another segment. Okay, so here also we need to specify both code segment and code segment address and instruction pointer or the displacement value address, but is in an indirect way. Indirect way means using or represent using a content of memory location or a content of register. Okay, so these are about different addressing modes that present in case of control transfer or branching instructions, inter-segment and intra-segment. And all the previous addressing modes, we can use all these previous addressing modes in sequential addressing, in case of sequential instruction execution. Okay, thank you.